Dear students, today I'll discuss with you some important MCQ from the gaseous state. The first question, a graph of Maxwell's distribution of molecular velocity is plotted below. So it is the velocity and the number of molecules. Okay. So out of the choice, which one the correct order for temperature? So C, out of the choices, B is the correct. T3 is greater than T2 is greater than T1. Second question, what is the correct increasing order of liquefiability of the gas? Okay, so out of the choices, A is the correct answer. Okay, so liquefiability depends on the compressibility factor. Question number 2, compressibility factor. That is known as Z. Okay, so the higher the compressibility factor at a pressure, the more difficult would it be to liquefy the gas. Okay, higher the compressibility factor, higher means the gas which needs more pressure to be liquefied, it is difficult to liquefy. But which needs less pressure, by applying less pressure, if it is liquefied, then it is easily liquefied. Okay, so out of the choices, A is the correct answer. A choice, H2 is less than nitrogen, is less than methane, is less than carbon dioxide. That means carbon dioxide is easily liquefiable. Next, 4 gram of argon whose molecular mass is 40 in a bulb at a temperature of 7K Tk temperature. This is temperature Tk has a pressure P atmosphere. When the bulb was placed in hot bath at a temperature 50 degrees centigrade more than the first one, 0.8 gram of the gas had to be removed to get the original pressure. Okay, that means pressure remaining constant. In both the cases, pressure remaining constant. And in first case and second case, the temperature difference is 50. Second case, temperature 50 degrees centigrade is extra. Okay, so what is T? What is T? The T is equal to how much? So these are the choices given. A 550 Kelvin, B 200 Kelvin, C is 100 Kelvin, D is 73 Kelvin. Okay, so let us say how to do it. Question number 3. We know P1 V1 is equal to N1 R T1. Similarly, P2 V2 is equal to N2 R T2. Okay, so both the cases P is constant, P remains constant. So P, we take P1 P1. Okay, we take P1 is equal to how much? N1 R T1 by V1. Here P2 is equal to N2 R T2 by V2. Okay, so what to do? We have to equating these two because pressure remain constant. So N1 R T1 and V1 is equal to N2 R T2 by V2. Okay, so say if P1 V1 is equal to P2 V2, if P1 P2 are same, then V2 V1 are also same. So V1 V2 you can cancel. So remaining is R cancel. So N1 T1 is equal to N2 T2. So N1 T1, let us say T1 is T. So what is T2? T plus 50 degree centigrade. So this is N2. Okay, so by solving this you will get T is equal to, and what is N1? N1 is given, 1 is 4 gram. N1 is equal to how much? N1 is equal to 4 by 40. So you will get 0.1 mole. Okay, So remaining for second case, 4 minus 0.8 is loss. Okay, so you will get 3.2 by 40, so you will get 0.08 mole. So putting all these things, N1, N2, T1, T2, you will get T is equal to 200 Kelvin. Okay, so out of the choice, B is the correct answer. Okay students, next, equal mass of hydrogen, helium and methane are mixed in empty container okay, at 300 Kelvin when total pressure is 2.6 atmosphere. The partial pressure of hydrogen in the mixture is how much? So these are the choices given. So what to do? We know there is a formula. Question number 4. There is a formula. What is the formula? Partial pressure of say H2 is equal to P total pressure multiplied mole fraction of H2. This is the relation. Okay, so by putting this relation, you calculate X2 mole fraction of H2. Say same mass is given, so X by 2. This is this much mole. For helium, you are taking mole of helium. You will take what? This is not mole fraction, this is mole of H2. So mole of helium, how much? You will take, say mole of helium is X by 4. Okay, similarly mole of methane, how much take? Mole of methane, you will take how much? Your X by 16. Okay, see the all why X are same? Because you are taking equal mass of these things are taken. So out of this you have to calculate the mole fraction of hydrogen. So how we will get? X by 2 by X by 2 plus X by 4 plus X by 16. Okay, so you will get how much? You will get 8 by 13. Okay, similarly for helium, X by for helium. Okay, so for helium you will get how much? You will get 4x 4 by 13. Okay, you will get 4 by 13. So according to this, the total pressure P total is given. You see here P total is given 2.6 atmosphere. Okay, P total is given. So for hydrogen, how will get P total? 2.6 multiplied 8 by 13. So you will get 1.6 atmosphere. Okay, so we will get 1.6 atmosphere. So out of the choice, B is the correct answer. Okay students, next, a flask containing air opening at atmosphere heated from 300 Kelvin to 500 Kelvin. The percentage of air escaped to the atmosphere is how much? Okay, so put another formula. You see how to do. N1 T1 is equal to N2 T2. Okay, therefore N1 by N2 is equal to T2 by T1. Okay, so what is N1? N1 by N2 is equal to T2 by T1. So what is T2 is given 500, N1 is given 300, so you will get 5 by 3. Okay, so the percentage, so what is N1? 5, N2 3, So you will get first N1 is there. Okay, so N2 is 3. So what is the percentage you will get? You will get 5, 20, you will get 60. Okay, so if 60%, okay, you will get 60%. What is the loss? The question is asked loss. The portion of air escaped. Okay, the portion of air escaped to the atmosphere is 100 minus 60, that is 40% escaped. Our remaining is 60. Okay, so choice B is the correct answer. Okay, students, or you can write like this: the N1 is 5, N2 is 3, so loss is 2, and you can multiply it 6%. So 5, 20, that is 40. You can take like this also. Okay, next question. So choice B is the correct answer. Next question: equal mass of hydrogen, helium and methane are mixed in empty container at 300 Kelvin. When total pressure is 2.6 atmosphere, the partial pressure of hydrogen in the mixture is how much? So question number 4 is repeated here. Okay, so choice B is the correct answer. Next, at STP, 1600 ml of oxygen diffuses through a porous partition in 1 second. What volume of CO2 will be diffused in the same time and under the same condition? So how to do this? You have to put this, you see, this formula, question number 7. So we know V1 by T1 grams of diffusion by V2 by T2 is equal to root over M2 by M1. Okay, so your time remains constant, time for same both. So V1 by V2 is how much? V1 by V2, you are taking 60 ml, 16 ml. Okay, 16 ml of O2 diffuses, and V2 you have to calculate it. What is M2? M2 is your what? CO2, that is 44. M1 is oxygen, that is 32. Root over is equal to 16 by V2. So then what is V2? By calculating V2, you will get how much? You will get 13.65 ml. 13.65 ml. So this is the choice A is the correct answer. Next, the molecular velocity of two gases at the same temperature are U1 and U2. Two velocities, U1 by U2. Their molecular masses are M1 and M2. Molecular mass is M1 and M2. Okay, which of the following expression are correct? Okay, so see, velocity, the molecular velocity of two gases at the same temperature are usually U1, U2, and their molecular masses are given M1 by 2. Which of the following expressions are correct? Okay, you see, our velocity, that velocity is directly proportional to molecular mass. Okay, so V1 by V2 is equal to root over M2 by M1. Okay, so by solving this, you will get this relation D, M1 U1 square, M1 U1 square or V1 square is equal to M2 V2 square or U2 square. So you will get this one. Next, correct statement. Out of these are the, which one is the correct statement? So see, at constant temperature, the kinetic energy of all the gas molecules is the same. So it is not correct. So at constant temperature, average kinetic energy of gas molecules remains constant, but kinetic energy of individual molecules may be differ. So choice B is the correct answer. Next, air contains 23% of oxygen and 77% of nitrogen by weight. You see, it is by weight. The percentage of air, the percentage of oxygen by volume is what? Okay, it is by weight and you have to calculate by for volume. What is the volume relation? You have to calculate. You see how to do. Question number 10. How to do? We know weight of oxygen by weight of nitrogen is equal to 23 by 77. The relation PV is equal to nRT. Okay. So PV, what is an weight by molecular mass RT. So you can change W is equal from this equation, weight is equal to PV by M, okay, by RT. Okay. So W is equal to PVM by RT. Okay. So here P is constant. What is given? Both are P is constant and your temperature is constant. So W is equal to what? R is constant. Then W is equal to your V and M. Okay. W is related to V and M. So therefore WO2, W of oxygen, weight of oxygen divided weight of nitrogen is equal to volume of oxygen and molecular weight of oxygen divided volume of nitrogen and molecular weight of nitrogen. Okay. So putting all these things, our aim is to calculate volume of oxygen by volume of nitrogen ratio. So putting all these things, molecular mass and weight, you will get 23 by 88. Okay students. So out of this choice, you are which one is the correct answer? B is the correct answer. 22.7. Okay students, have a good day.